Good morning, friends. Today we have to see the next question. How will you determine the thermodynamic parameters such as the free energy change, delta H change means the enthalpy change, delta H change is nothing but the entropy change, and equilibrium constant from the EMF measurement. How that E cell will be useful in determination of these parameters: free energy, enthalpy, entropy, and equilibrium constant. First of all, we will talk about free energy change. As you know, we have seen already about the free energy that is energy associated with the system, any system or say any molecule. We called it as a free energy. Any work by a cell can only done at expense of the decrease of the free energy, which is given by here you can see, which is given by that particular Gibbs free energy equation as delta G is equal to minus NFE cell, where N is number of electrons, F is the Faraday's constant, whose values is about the 96500 coulomb, and the E cell is nothing but the some electrode potential of the cell expressed in the volt. And the standard free energy is given by delta G0 is equal to minus NFE0 cell. That is a standard EMF that we have seen, standard potential. Then enthalpy change and the entropy change. By using the Gibbs-Helmholtz equation, enthalpy and entropy can be calculated. The basic equation, Gibbs-Helmholtz equation that we have to use for the entropy, there is a delta G upon delta T is equal to minus S. But delta G, when you substitute for the delta G, that is a minus NFE. Yeah, here in this formula, you can see here when you substitute for this particular delta G, this is the NFE cell, and after that means you will get delta G d delta G upon d delta T is equal to minus d NFE cell upon dt, which is equal to minus delta S. Therefore, delta S is equal to d in bracket NFE cell upon dt. That is the delta S is equal to NF will be the we will take the outside the bracket, and dE cell upon dt, that is nothing but the temperature coefficient. It will calculate it as a E2 minus E1 upon T2 minus T1. Same way you can calculate enthalpy. Enthalpy, for the enthalpy, delta G is equal to delta H minus T delta S. Now here we will substitute for the delta S. After substituting for the delta S, we will get the same terms, and after substitution of all these things, delta H is equal to delta G minus T in bracket d delta G upon dt. And when you substitute for the delta G in the both the terms, then minus NFE cell minus T delta G d delta G upon dt. When you take the minus NF common, at that time E cell plus T in bracket d E cell upon dt, and d E cell upon dt is nothing but a temperature coefficient. By knowing the temperature coefficient, you can easily calculate this particular delta S, change in entropy and change in enthalpy, that you have to remember. Then last and important, equilibrium constant. As we know, for any reaction that Gibbs free energy is given by the equation delta G is equal to delta G0 plus RT ln Q. At equilibrium, delta G is equal to 0. Therefore, delta G0 is equal to minus RT ln Q. Since Q is equal to K, therefore minus NFE. You can substitute for the delta G0. Minus NFE0 is equal to minus RT ln K. NFE0 is equal to RT ln K. ln K is equal to NFE0 upon RT. You can convert that natural log into the log to the base 10 by using the formula 2.303 log K is equal to NFE0 by RT. Log K is equal to NFE0 upon 2.303 RT. At 298 Kelvin, when you take this Faraday 96500 and all these parameter, when you take the at 298 Kelvin, log K is equal to Ne0 upon 0.05916 RT. At a particular 298 Kelvin, the temperature and that gas constant will goes. Then log K is equal to N0. That please make the correction. N0 you can see here instead of at 298 Kelvin, the log K is equal to Ne0 upon 0.05916. Okay, this is whole about this. By using the EMF, you can determine the free energy change, enthalpy change, and the entropy change easily, and the equilibrium constant. It is very much important question as far as the exam point of view. 5 marks question will be there based on this part. Please go through it, and in the MCQ purpose also it will come. Okay, so here we will stop. If you have any query, you can ask. Thank you.